All right, good evening, everyone. My name is Todd Shea. I'm the meteorologist in charge of the La Crosse National Weather Service. And also presenting tonight will be Kevin Scow, one of our lead forecasters at our office. And Kevin will be talking about some of the details of how we've done some of the damage surveying and determined tornado paths and tornado determinations here over the last month or so. So I'm going to go ahead and start. And again, we really appreciate everyone for joining us tonight in review of the historic December 15th and 16th storm. I figured there'd be pretty good interest in this event. Again, broke a lot of records, which we'll talk about. And, really was a unusual event by all standards. So we won't be able to cover everything tonight, but we will go over a lot of the overview and some of the actions that we took, and maybe give you a little bit more, like I said, view of how some of the tornado determinations were made, which is turning out to be one of the bigger tornado outbreaks in U.S. history, of all things. So I'm going to go ahead and get started here, and I kind of wanted to start with a quick poll question here. So this, you might have to, if you're watching on PC, you might have to interact with the PC, otherwise the computer. Otherwise, you can just kind of sit back and enjoy the presentation. We will take some questions at the end if you want to use the GoToWebinar interface at all. But the first question we wanted to ask here is, were you personally impacted by the December 15th and 16th storms? And so we'll let everyone just take a second here to vote, if you will. And we had about, about 175 people register. Not 175 people will probably show up here tonight, but just kind of get a feel for how the storms kind of impacted the area here. Let's see, we'll give you a few more seconds here. All right, looks like the results are kind of slowing down. So let's see if I can get this displayed. And all right, let's see here. Sorry for the delay here. All right, I'm going to share the poll questions here, and it looks like of all the people attending tonight, just over half were impacted by the storm. So that kind of gives us just a little bit of a kind of a view of people that kind of went through this, if you will. So let's go ahead and dive back into the slides here. Appreciate you taking the time to go through those. All right, let's see here. Okay, here's an overview of kind of the storm. Of course, as I'll mention probably several times here tonight, easily a historic, rare December type storm. And this storm kind of posed a lot of threats in a sense that it had two main impacts here. So multiple things to worry about. We not only had the brief, fast moving line of thunderstorms that raked the area with the tornadoes that we'll talk about and wind damage in itself, but one of the more high confidence items that we had to kind of message and be concerned with that night was also several hours of very strong winds behind it. So it had, two main impacts that were kind of the dangerous part. With that, then the area was covered by not only a high wind watch, a day or two in advance, again, a high confidence in the winds, but also a moderate risk of severe thunderstorms and a tornado watch. very unprecedented, as you'll learn, for certainly mid-December. Widespread wind damage, of course, occurred, and we've probably tallied up to about 27 tornadoes now, including 4 EF2s and 14 EF1s as part of that collection of tornadoes. Interestingly enough, and we'll get into some of the records with this event, but in between the line of thunderstorms and the very strong gusty winds that occurred later that evening, we had a period of some smoke and dust that came up from the Central Plains that actually reduced visibility across much of the region down to about 3 to 5 miles, and there was actually a smell of smoke in the air in between, which kind of caught people off guard to a certain extent. All right. All right, so this is another slide courtesy of our Chicago office that just kind of gives you an overview of what all occurred that particular evening. Again, so many, all these dots are high thunderstorm winds. Reds were some of the tornado reports early on. There was a little bit of hail, but this was primarily a wind and tornado event. And of course, there was just strong winds in the gray that occurred later that night too. So just an unprecedented variety of reports and impacts across really the entire Midwest. In fact, of course, the phrase derecho, as this storm was classified, basically comes from a certain long-lived line of strong thunderstorms associated with the wind gusts with those storms, and this certainly qualified as a derecho as it moved through the upper Midwest. Another graphic that just kind of shows you, this was from our headquarters, if you will, of all these bright oranges and reds depicting peak wind gusts that occurred in that 24 to 36 hour time frame as that entire storm system moved out of the southern Rockies and through the Great Lakes. So you can see some of the higher wind gusts in each state. Again, just very impactful and damaging from the Rockies all the way to the Great Lakes there. This particular event, is such a big event that it actually has its own Wikipedia page. I won't go through, the details of this, but you can certainly learn more about the whole event on using Wikipedia. And again, it has the total now up to about 118 tornadoes with this event. And one of the graphics that you might see on there too, kind of depicting in some of the shades the outlook that was out that going into that evening for severe weather, and some of the tornado warnings that you see in these red shapes here, these polygons, including some of the tornadoes depicted by these triangles that you can see, not only in our area here in southeast Minnesota, western Wisconsin, and northeast Iowa, but through much of the state of Iowa and back into the plains. So we'll get into those details. Now, this is an animation showing, courtesy of the Iowa Environment Mesonet, Daryl Hersman, who runs that out of Ames, Iowa area, showing the loop of the radar returns that night, plus all of the warnings. The yellow boxes you see moving through are severe thunderstorm warnings, and there were also red kind of polygons or boxes showing up there. Those are the tornado warnings. And all the dots are depicted by extreme thunderstorm wind gusts, if you will. And while I'm not going to talk about it, but the derecho that hit parts of Iowa, Illinois back in 2010 in August, which is certainly a big impactful event, actually didn't have quite as many of these significant wind gusts. It still had more than its share of damage, certainly, but this one might have the record for the most higher end wind gusts associated with it. So you can kind of see how that followed along with that line of storms. So just a really kind of a great looking animation here of that entire line of storms coming through. And again, that was just one facet of this entire event, was that line of storms. But then, of course, we had the strong winds that came around behind it as we moved into the late evening and the overnight hours. So if you were to look at all the damaging wind and tornado reports that we've actually documented through damage surveys, this is a look from, again, parts of Nebraska, Kansas, all the way into our area here in Wisconsin. And you can see all of the work that's being done by the National Weather Service offices in in documenting and surveying the different locations. And then just looking at tornado tracks closer to our area here, the National Weather Service's service area is kind of depicted in this red outline. In fact, these red outlines depict National Weather Service service areas. But right in the center here is our particular offices area. And you can see the different color lines and dots, if you will, depict the different tornadoes that we have documented through this process. And we have 27 of these that have crossed into our area. But again, quite a few more as you go into the Twin Cities service area and down into the Des Moines National Weather Service area in central Iowa. Interestingly enough, most of our documented tornadoes in southeast Minnesota and northeast Iowa were luckily of the small variety, albeit very fast moving tornadoes. Most of them were fairly short-lived, which is kind of an aspect or a challenge with this particular event. But the stronger tornadoes that we've been able to document, at least in our area, were actually up along and northeast of Interstate 94, interestingly enough. And while you might be wondering, well, why was there these yellow tracks down here in Iowa where there was stronger tornadoes? But then there's kind of this break, and then you have to go quite a ways north to find more of that more intense tornado damage. And that was likely because of the way the frontal boundaries, if you will, were moving through the area. And as storms approach this area in parts of north central Wisconsin, they kind of align with that front and were able to kind of come together and produce, again, short-lived but more intense tornado damage. So let's go back and look at some of the records set by this particular December storm. Well, first of all, maybe not as impactful, but interestingly, we had our warmest December temperatures ever on this day, December 15th, 2021. Warmest readings ever on a December day. And of course, this helped fuel this entire event, right? Anytime you get temperatures in the 60s to near 70 degrees, and we were able, more importantly, to get the moisture that these thunderstorms needed out ahead of this storm system. So we had all the ingredients, if you will, even though it was mid-December, for severe thunderstorms. In our particular service area, the La Crosse service area, we ended up having the most tornadoes ever for one event, more than any event we've had in the months of June, months of July, but ever. And of course, probably more importantly, our first December tornadoes ever. We had never had a tornado in our area during meteorological winter, December, February, or tornado. And now, of course, we go from that to quite a few, as we'll show you. Interestingly, it was also the first December tornado ever documented in the state of Minnesota. Iowa and Wisconsin had at least a few tornadoes through the years in Decembers, but this was the first ever in Minnesota, and it wasn't just one. There were numerous ones documented in Minnesota for this event. The first December Derecho documented in the United States. Again, a Derecho is a label, if you will. It's not really, I guess, a super official term, but it's a label that is depicted for a long-lived line of damaging thunderstorm wind gusts. And this was the first one ever documented in the month of December. The thunderstorm wind gusts and strong winds we had that night also produced some of the strongest wind gusts ever recorded at the Rochester, which is KRST airport, and in La Crosse, which is KLSE. I know the Rochester airport on that particular evening had a wind gust to 77 miles per hour at 7:45 in the evening when the thunderstorms came through, and then also another 77 mile per hour wind gusts at about 11:25 later that evening when the strong, pressure winds, or the what we would call gradient winds, came through with the main storm system. In lines with the Derecho definition too, this had the most number of 75 mile per hour wind gusts ever recorded with an event in the United States. And so that kind of goes through with one of the stronger Derechos ever documented, and the latest moderate risk in the season ever issued by the Storm Prediction Center, and this far north too, which is pretty rare. And a moderate risk is that kind of level 4 out of 5 in the risk scale that the Storm Prediction Center uses. So it's pretty rare for us in the upper Midwest, if you will, to get a moderate risk in the middle of summer. And here we ended up with one in December. Just looking at some of these records graphically, here is the temperature looked for La Crosse high and low temperatures for the month of December, and I highlighted here in the middle December 15th. And sure enough, again, not only a record for the date, but a record for the warmest December ever recorded temperature. And I believe in La Crosse, at least, we hit 69 degrees on that day. Here's an interesting graphic I saw recently on social media. It's the December tornado watches ever issued by the Storm Prediction Center from 2002 to 2021. And yes, this whole pink or magenta area in our area here that I kind of highlighted with this oval or this box shape was that event, the December 15th tornado watch for our area. So up until this past December, there had never been a tornado watch, issued this far north. Maybe into parts of Illinois and in Iowa, but nothing this far north. Other graphics that were put together by different groups. Here's one by the Storm Prediction Center, kind of showing their moderate risk, if you will, in these brighter red colors, and then all the dots depicting the stronger wind gusts. Again, probably the new record for the highest number of 75 plus mile per hour wind gust reports that came in from any one storm system. And a graphic that our climate program leader put together in our office, number of tornadoes by month in our service area. And it is interesting to note, again, up until this event, we had never had a December tornado, and all of a sudden we have 27. So in the 72 years of record that this depicts of documented tornadoes in our area, we went, again, from in December from 0 all the way up to 27, jumping a lot of the other months that had, previous minimum numbers. We can't forget too that this December 15th, 16th, total event wasn't the only significant event that occurred in the United States. A few days earlier, December 10th, when we had snow across our area, interestingly enough, there's some very devastating and long-lived tornadoes that impacted parts of the mid-Mississippi and parts of the Ohio River Valley. So December was a pretty active month when it came to tornadoes, all things considered. Going back to some of the records, just real quick, with this strong a storm system, we set at least the top 10 lowest December sea level pressures. Here's at the Rochester Airport, maybe the 6th lowest on record. And that was across the 6th lowest. And at Rochester, the 2nd lowest pressure reading ever observed. So certainly never seen a pressure reading that low in more recent years. So when we look at kind of all the different pieces of information that we put out, what we would call products, if you will, in the National Weather Service, leading up to and through that event, our office issued, of course, a high wind watch ahead of the storms. Something that we had high confidence of was at least getting damaging wind. That preceded into a high wind warning. Of course, we had a tornado watch issued that day, a total of 12 severe thunderstorm warnings, 8 tornado warnings, and follow-up statements, 47 total. So that's pretty significant and a very busy or active weather event in our books, if you will. And over 80 severe weather reports received that evening. And of course, we ended up with getting a lot more information later on, of course, from that area. Here's another graphic, again, showing the yellow boxes or polygons, if you hear, were all the severe thunderstorm warnings that were issued, and the orange or red were the tornado warnings as the storms moved through. So, by all means, we did not issue, or the National Weather Service in general did not issue tornado warnings on the entire line. We did our best at our office, and as did the other National Weather Service offices, to try to pick out those areas of the storm that were more likely to produce tornadoes. It was a challenging event, because of the speed and that threat between tornadoes and damaging wind. So we'll get into those challenges here in a little bit. Let's talk a little bit about the predictability of this, because there are certainly some severe weather events that are easier to predict or have a higher confidence, if you will, than others. So one of the challenges with this event was, of course, the time of year. And typically in December, with colder temperatures, it's a lot of times difficult to get those temperatures and the moisture values that you might associate with thunderstorms this far north. So early on, let's say several days in advance, maybe 4 to 6 days in advance, the predictability in this storm was very low, if you will, maybe low to medium, if you will. A lot of the concerns, both by the Storm Prediction Center and our own local forecasters was we knew there would be a lot of what we would call wind shear in the areas. And these are some of the quotes from some of our discussions leading up to it, if you will. But the instability, and again, that gets back to the temperature, the moisture, was going to keep things kind of limited. We just, again, it's very unusual to get that kind of moisture this far north, that instability in mid-December. So here's another day leading up to it. Instability is forecast to remain weak. This should keep severe threat marginal. And again, more comments among the forecasters, if you will. So there just wasn't a lot of confidence days in advance that this would actually materialize into a fairly widespread event. But as the event drew closer, and this is very typical, I guess, of almost any kind of weather systems, hopefully as we get closer to it, our confidence grows. And that was the case. In the more short term, especially 24 hours out or so, confidence really started to grow that this was going to become a fairly significant event. This was one of the discussions out of the Storm Prediction Center, and while I won't get into the technical jargon, if you will here, but they were starting to say about a day in advance that this has the potential to have widespread wind damage, high-end wind gusts, embedded circulations capable of producing fast-moving tornadoes, some of which could be strong. And so, that's when the confidence really started growing, and there was a steady ramp up as we got closer to the event, if you will. Now, as the event drew closer, of course, we started picking up locally here that we would get those warmer temperatures, and if that higher moisture values could feed these storms, that we were looking at a pretty dangerous type of scenario. So some of the discussions or some of the quotes that we used in our discussions was, this event pretty much is a meteorological, or every meteorological parameter that was associated with this event will exceed climatology. In other words, exceed what we would typically see in mid-December. Here's another one. The expected magnitude of this widespread, prolonged historic event is highly concerning. We'll continue to beef up messaging to stress its rarity and impact of severity. So we were, as the event drew closer, our confidence was growing, and it also became very clear that, again, this was an extremely concerning scenario, and it had a lot of dangers in place. And so, again, that was some of our thoughts. It's the last one. Again, I won't read it in detail here, but we started trying to message the idea of significant higher end wind gusts with very fast storm motions. Wind gusts could produce, numerous gusts of 60 to 70 miles per hour. And given the kind of the wind setup in the atmosphere, that fast-moving tornadoes could occur and potentially have some strong ones. Again, certainly a rare environment for mid-December. So that was some of the forecast thinking. And then, of course, our job is to get that into messaging, and how do we communicate that to the public, but also, our partners in the emergency management communities, our partners with storm spotters, and so on. Let's look at a few more of the pieces of information that were out there. This was the day 3 Storm Prediction Center outlook. So, and again, this is not a blame game on anything. It's more of a look at how the confidence grew. So again, a couple days out, we were just in a level 1 out of 5, a marginal outlook for the possibility that some severe weather could come together. Again, a lot of questions on instability. The day before, we were up to a level 2. Especially west of the Mississippi River. But even then, it was highlighted the main threat area pretty well. And then, of course, there was a little bit of a tornado threat area included, that if severe weather did materialize, that they could very well become tornadic given the stronger winds in the atmosphere with that particular day. And then the day of, and this was the outlook issued during the early morning hours from the Storm Prediction Center. This was on December 15th, and boom, we're up to a level 4 out of 5, or a moderate risk of severe weather right across most of the region here. And I must say, I typically don't sleep well on nights going into one of these more dangerous scenarios. And I think a lot of us at the National Weather Service La Crosse office, and I think a lot of meteorologists around the upper Midwest here, saw this outlook, and knowing what we knew about the data, because of course the outlook is just that, it's just highlighting the main risk area. But we all knew that this was becoming a very dangerous area, and it was kind of like I wouldn't say a kick in the stomach, but it made you feel like wow, this is really dangerous, and it's very concerning when the setup comes along like this. So when we looked at the tornado potential that day, kind of this highlighted or hatched in area of 10% or higher is pretty significant for tornado forecasts. So all of a sudden now we're up to a fairly good likelihood of tornadoes, albeit fast moving. And even the wind damage was expected to be very widespread and intense. And that's where we see this 45% risk in a hatched area. So that means in any spot in this area, the likelihood of getting damaging wind was, almost approaching 50%, which is, again, a pretty high number. So again, overall, these risks were very high for any time of year, let alone December. This is kind of a close-up of that tornado outlook, if you will. The 10 to 14% hatched in our area. The hatched area means that there is significant, or there could be the probability of significant tornadoes, or EF2s or higher, and of course we did have some of those. Again, another look at that risk area and some of the severe weather reports that day, so you can see it lined up very well. So let's look at some challenges here that we were faced as, I guess, meteorologists, and and how we're going to work with all our partner groups. First of all, the time of year. We talked about this. It's December. People are not anticipating this. Are they even going to be paying attention to the threat of tornadoes? So and just getting confidence in the forecast is a challenge, given that it's mid-December. The time of day. Remember, it gets dark early in December here, and so it was going to be dark by 5 something, and yet the storms weren't going to come through till 6 to 10 p.m., 6 to 11, and so that was very concerning. The speed of the storms, boy, that played into factor on so many levels. Kevin's going to talk about the speed of storms and how that impacts storm surveying, but how do we message that? How are we going to handle our warnings? How is the public going to be able to, prepare themselves, given that storms were going to be moving at 60 to 70 miles per hour? The intensity of the storms, again, they were going to be very short but very intense as they move through. So we had to message that and make sure people know that it was going to hit quick and it was going to hit strong, and then the storms were going to move on through. Remember, we had dual threats. We had the damaging wind and tornado threats, but we were also trying to get that word out that after that line of thunderstorms moved through, we were going to have some almost as strong of pressure winds, gradient winds associated with the large low pressure area through the night. And so they had, again, multifaceted threats here. How do we express the seriousness of this, particular storm? Those are all things that we had to kind of play into this, again, given the time of year too. How do we communicate with our partners on the safety aspects, given the time of day at night? What are spotters going to do different? That sort of thing. What about power loss? Behind this cold front and these strong winds was going to be sharply colder temperatures, which gets into some of the challenges when we did the damage surveys that Kevin's going to get into. But what happens if people lose power and then they need that for heating? So that was something we had to try to think about and message and work with our partners on. And of course, not to be outdone, when you get warm temperatures like that, so unusually warm, we ended up with dense fog early that morning, and that led to a fatality in southeast Minnesota, north of Rochester, Minnesota, along Highway 52. And so, you're trying to alert people about strong winds, you're trying to alert people about tornado threats, but we also had to deal with some dense fog that morning and those associated threats. So, it posed a lot of challenges there. So when we talk about the actions and the services that we took at the National Weather Service La Crosse, is, we did all we could. It's like getting the entire toolbox out, if you will, right? We tried to use the maximum in any unique communication that we could think of. So we did our typical, we email some of our partners, if you will. We put together special slide sets. We hit social media with a variety of different graphics and messaging so that people had that information, but also could share it. That force multiplier of people sharing the information out there. We tried to word our outlooks in a certain way. We had a news story up on our webpage. Plus, we did conduct a webinar for, again, our partner groups, our emergency management officials and dispatch and highway and schools and all that that day, and had over 200 people in attendance on that webinar. We also took a look at our staffing. and we utilized as much as we could. We didn't have everyone in, but we filled all of our possible positions, if you will. We did extra preparation in a sense that we highly checked our computer systems, rebooted them, made sure everything was in order. We actually tested our generators to make sure that they would come on in case we lost power. We don't always test them, but this was such a high-end event that we took that extra step just as a double precaution, I guess you could say. And we internally did a lot of what we call shift-to-shift preparation, where one of our shifts, like maybe the overnight shift ahead of the day shift, for example, put a bunch of safety graphics queued up, ready to go out in social media so that the day shift could focus on the details of the forecast. So we had a lot of internal cooperation that really helped out. And then we also had a lot of internal discussion going on too. We had talks about how are we going to handle these scenarios of the fast-moving storms? How are we going to use our spotters? How is it going to be different than mid-July, that sort of thing? We sent extra emails to our emergency managers and spotters telling them about the fast nature of the storms, and that spotter groups probably were not recommended to go out because of the danger of the strong, fast-moving storms and the darkness, if you will. We alerted our dispatch centers that due to the speed of the storms, we wouldn't be able to give them as much heads up and things like that. So a lot of stuff that we might not normally do on a what we would call a regular round of severe weather. We also did a lot of our own internal research on records for December, the rarity, the perspective, little details, getting into some of the climatology, if you will, to pose that to the public, to show people that this was not another typical thunderstorm day, if you will. And of course, we had a lot of internal communication between our office and the neighboring National Weather Service offices, and teamwork when we were out doing damage surveys, and communication with the state, and meeting up with emergency managers and so on. So there was just a lot to take in and a lot of things to think through with this particular storm. I mentioned staffing. Again, this was kind of an all hands on deck. And now, while we didn't have everyone in our office that day because we just simply don't have enough computers for everyone, we had as many people as we could use and fill spots for. And what's really, I guess, cool to me as a manager in the National Weather Service is on these type of events, the dedicated members of our staff, and this is true throughout the National Weather Service, they know this is the event. This is what we are here for. And this was an event where everyone was volunteering to come on. People that had worked all day, they wanted to come back and be part of it. We had, again, every desk full. We had one person just focusing on the severe weather threat of the warnings. We had another person looking at the tornado potential. We had someone looking at the environment. We had communicators, coordinators, people just dedicated to social media, and so on and so on. We always try to make sure that we're staffed to match the event. So this was, again, an all hands on type event. So just to kind of keep moving on here, again, this was a very historic event. This is some of the graphics that we put together. This first one was kind of highlighting the strong winds that we were going to have. We had other events talking about the severe thunderstorm potential and the timing, 6 to 11, trying to highlight the highest risk, if you will, here. We had a lot of different safety type messaging, alerting people to that they wouldn't have a lot of time in some cases from when they're alerted to time they need to get to the basement because of the fast moving nature of these storms. So we were trying to think of all the different elements that might come into play here. Some of our social media graphics, here's one that we used the day before, kind of highlighting a forecast showing the purple colors here would be the strong wind gusts with the line of thunderstorms coming through, but behind it, we were going to have another corridor of very strong winds. We tried to use social media of ongoing severe weather back to our southwest before it even got up into our area. So this was issued, a couple hours before it raced into our area. So we could tell people that this is occurring and this will come into our area in a couple hours. So it kind of gives them that ground truth, if you will. And, just kind of highlighting or sharing that we, with everyone that, we were fully staffed and ready to go. And interestingly enough, a graphic that kind of personalizes our work got some of the highest like numbers of all the social media that we issued. Some of the graphics that we put together in our webinars look like this, where we again highlighted that risk, tried to put timing in there. We used kind of unique graphs like this where it highlighted the strongest winds, not only with the line of thunderstorms, but later in the evening and into the overnight hours across most of our communities is when we were going to see kind of the strongest sustained winds that were going to be buffeting the region overnight. Again, we tried to think of all the non-traditional things. We really urged our partners to be thinking about buildings with larger span roofs, people that are out shopping. What are they going to do when they're in big box stores? The highway departments, where they prep to clean up debris from fallen trees and branches. That the confidence was high in at least wind damage. And so we knew we were going to have a lot of trees down, a lot of branches, maybe power lines. This was leading up to the holiday season, holiday decorations, the strong storm speeds, and so on. And again, we tried to remind people once that line of storms moved through, it wasn't done. It wasn't the end of the whole event. All right, so that's kind of the big overview of everything. Before I pass it on to Kevin, for any of you that are logged in to kind of wanted to see some of the meteorology, if you will, we're going to get a little nerdy here, but I'm not going to get too detailed. But I just wanted to show some of the weather parameters. This was kind of a weather map, if you will, in the afternoon. This red cusp line here, the warm front, and we had temperatures again in the mid 60s to lower 70s, pushing up to our area from the south. And you can kind of see the low pressure area here in Nebraska. And as I move forward, here's 6 o'clock and then 9 o'clock. You can see how fast this storm was moving up to the north, and the fronts, if you will, the cold and warm fronts were sweeping through very rapidly. So that was just kind of a depiction. And the closer these black lines are on this map here, kind of would demonstrate the stronger wind gusts. And so even after the cold front came through, we still had hours of very strong wind gusts. Another kind of technical graphic phrase here, this is an animation, hopefully it's showing okay, is kind of what we would call the storm relative helicity. So this is just the amount of turning, if you will, kind of in the atmosphere, and the higher the number, the more dangerous. And so you can kind of see as this loop goes through it kind of winds up, and we get up to values in the 800s in western Wisconsin, especially going in the evening. And if I took screen captures here, and you can kind of see 7 o'clock, this peak is in northern Iowa. 8 o'clock, it's in southeast Minnesota. And by 9 o'clock, it's already up here along and northeast of Interstate 94 in Wisconsin, and dramatically increasing. So it just kind of showed the dramatic turning of the atmosphere if we could get any strong thunderstorms to move through. So kind of nerdy, kind of meteorological, but it's just highlighting that the setup for tornadoes was just kind of skyrocketing as it went through that night. All right, let's see. Here's a little animation showing the satellite loop, and you can kind of see the spiral, if you will, in this satellite loop. Hopefully it shows okay through the bandwidth of this webinar. But a very intense storm system overall. You can kind of see how it wound up as it moved out of Colorado. And part of that, as it wound up, and here's a screen still shot, you can kind of see that spiral, if you will. As it wound up, it started picking up dust and smoke from wildfires in Kansas that kind of got trapped in this region behind the line of storms and out in front of the strongest winds. So here's another shot of that. You can kind of see these brown colors spiraled in with the white. That's the smoke and dust that's getting pulled up into the storm system. And this whole thing just kind of kept moving towards our area as we got into the evening hours. So quickly, I talked about that smoke, if you will. This is kind of a look at visibilities being reported across the state of Iowa. And at 8 p.m., the line of thunderstorms was here in northeast Iowa. So you can see this 2.5 mile and this contour. That's the line of storms. And if you look back towards central and western Iowa, you start to see a lot of 2 miles to about 5 miles. And as we move through the evening, you can kind of see that region continue to march into northeast Iowa. And then, of course, it goes into neighboring Minnesota and Wisconsin. But as the strong winds pushed all that out, then going into the overnight hours, of course, the visibilities all came up. But we were noting at our office between the line of storms and until the strongest backside winds got in, a strong smell of smoke that kind of, and a reduction in visibility at our office and across, parts of the region. That lasted a couple hours until that smoke kind of got pushed out. A quick few radar images, and then I'll pass it on to Kevin here. This is kind of a loop. I don't know how well it will depict in the webinar setting here, but you can kind of see this is just the line of thunderstorms as it marched northeast from parts of central Iowa, southern Minnesota, across our area going into the evening. Again, very fast moving storm motions, 60 to 75 miles per hour or so. So it didn't take long for the whole thing to advance through the area. I do have a couple of screenshots of some of the tornadoes. Again, I'm not going to go into details, but the brighter reds and purple colors here would be the stronger returns on radar. Typically large raindrops or maybe hail, but not in this case, mainly rain. And you can kind of see how there's little appendages here, and sure enough, these red and green colors here, some rotation, noted on the Doppler radars as well. Here's another tornado moment in northeast Iowa near North Washington, Iowa, and a little bit of rotation on radar, but again, this kind of bowing area of the line as it moves through. Another moment here where there were some tornadoes in southeast Minnesota. You see a little bit of this curl, but as meteorologists, we're looking for these little notches and different aspects of this line of the storms, and then of course the rotational aspects of that line as well. And a couple of last ones, some of the stronger tornadoes in parts of north central Wisconsin showed up fairly well. So here is Neillsville, Wisconsin, in interstate, this is east of Eau Claire, Wisconsin, if you will. So Interstate 94 kind of goes through here, but here's again the storms and some of that rotation. And then as it advanced further northeast and did some of its worst damage west of Neillsville, Wisconsin, strong EF2 damage, maybe even low end EF3. You can kind of see how the radar looked and some of that rotation. And the last one I'll show here is another tornado moment near the community of Christie, or between Neillsville and Christie, Wisconsin. Kind of a little bit of this wraparound on the radar here, but some rotation as well. So those are just some of the radar highlights depicted on some of the tornado events with the storms. So, and I talked about challenges. There were a lot of challenges with this event, and documenting all of this too is a task that we do as well. And there's a lot of reasons why we need to document storm damage, but of course we need to kind of classify if it was tornado or wind damage as best we can. Local officials need that information, insurance companies, and of course us as meteorologists. In summary of these events and doing research, we want to know what occurred with these events. So the damage survey process is pretty involved. And with that, then, I am going to pass this on to Kevin Scow, one of our lead forecasters. And let me make him the presenter here.
All right,
I'll let
Todd,
you take it over, Kevin.
All right, thank you. Let's see, which screen are you guys seeing? Are you seeing the small one or the main screen here? Hey, Todd, which screen can you guys see here?
Kevin, I'm seeing both. I'm seeing your preview slide too.
Oh. How's that?
There you go. Yep, looks good.
Perfect. Excellent. Thanks again, Todd. And as Todd said, Todd covered the lead up into the event, the actions that we took, and also the meteorology behind the event. And so this is going to focus on the actions that we in the Weather Service took in the days and weeks, and in some case months after the event. And our work was far, far from done when the storms moved out into Wisconsin and out of our area. And so we had a deluge of damage reports come into our office here from a variety of sources. We had Facebook posts, we had social, we had Twitter reports, we had emails coming in to various accounts, chats coming in from our EMs and our media partners all across this very broad area that was roughly about 60 miles wide and about 200 miles long of these damage reports. And so trying to sort this out, and they were coming in, we would get a few one day and then additional ones. So they came in all through the course of several weeks. So trying to triangulate and get teams out there to look at all the damage was quite a heavy task for us. And the challenges, Todd has alluded to many of these already. The tornadoes themselves were incredibly fast moving, upwards of 70 miles per hour. They were only short-lived, lasting for just a few minutes, but could cover quite a distance for their duration. They were what we call quasi-linear convective system tornadoes. They tend to be very shallow. They're not very deep. In that case, they're generally undersampled by the radar at any distances beyond roughly 50 to 70 miles. And as we said earlier, this was at night, and many of these tornadoes were actually on the back side of the storm, and they were hidden by rain. We never had anyone call in with a confirmed visual report of any of these tornadoes. And of course, they were everywhere across this vast swath of area to look at. And to add insult to injury, as you may, these tornado winds were often surrounded by non-tornadic winds, either during the event, the storms themselves, or those high winds that came in on the backside. And so trying to sort all that out proved to be an additional challenge. And of course, it's winter. There's no green vegetation to look at, which is a lot easier to spot for damage, whether from the ground or from the satellite. On the flip side, without having all that green vegetation around, you can actually see deeper into tree stands and see more damage back there if there was any. So there was a little bit of a silver lining there. The satellite imagery we acquired, it took a long time to get, as it was hampered by cloud cover, and then eventually the snow that came a few weeks later really hampered the ability to use the satellite data in certain regions. The iPads that we used to go out and survey did not like that cold weather. There was one instance where the iPad battery, a fully charged iPad battery, just gave out after a few minutes in the cold. And trying to type it on those iPads without wearing gloves and in those teens and 20-degree temperatures was no fun whatsoever for the ground survey teams. And then another aspect that some people may not realize is it's the holiday season. This was 10 days before Christmas, and we have staff who have holiday plans with their families as well. So additional staff beyond our core group of forecasters who are here 24/7 to get out and get everywhere possible in a timely manner proved to be a little bit of an undertaking, but we got it done. Other additional factors, the terrain areas around the Mississippi River Valley really complicated some of these wind patterns, and especially with these fast-moving tornadoes only staying over a certain area for seconds, those terrain really caused some weird things, patterns that were observed from the ground. And this is a testament to the area, that it was a very fast cleanup response. People got out and helped their neighbors and cleaned it up very, very quickly. But from a damage survey perspective, a lot of the key things that we look at is for damage patterns got removed beyond, say, a week after the event. And so trying to decide what actually happened proved to be even an additional challenge. Here are just some of the damage photos from the event. The majority of the damage that we saw was to farm outbuildings and trees, but there were a few tornadoes that went through more populated areas, such as Rudd, Iowa. Where we had multiple houses damaged. This is actually an old community church that was turned, I believe, into the town or county museum that got pretty heavily destroyed. And some of our worst damage occurred to a house over west in Neillsville, where a single house was wiped off its foundation and thrown into the trees. But this is just a sampling of some of the damage that we saw in the weeks after the event. So I wanted to touch on a few of those aspects a couple of slides back about how complicated this survey was. First of all, from a radar perspective, just going through and looking at the radar and saying, hey, can we find where these tornadoes possibly were just based on radar? We did see a lot of circulations on radar throughout this entire event. And sometimes I went through and counted, I saw upwards of 7 potential tornadic circulations at one time. And however, based on the ground survey results, and this is not surprising, that these circulations were only correlated with tornadoes for just a short amount of their lifespan, or these circulations, all we could find was downburst wind damage from them, and that's not uncommon. If you leverage other radar products beyond just your simple reflectivity and velocity, you can help narrow down locations to survey. A couple that we used were the spectrum width product, which looks at the variability of the wind speed. So basically, is there in addition to velocity, where is there swirl in the atmosphere is what we're looking at. And then correlation coefficient, and one of our dual pole products that has been around for about a decade now, where we can try and find debris being lofted up by these tornadoes and hit on where that circulation with high confidence, where that circulation could have been producing a tornado. The tornadic wind fields behave very differently for tornadoes that are moving at such high rates of speed. The more typical tornado that you could see here on the right, on the left side of the screen here, say it's moving at about 20 miles per hour, and any tornado that's moving at a forward speed that's rotating cyclonically is going to have its damage enhanced on the right side of its track, or the right flank of its track, just simply owing to the fact that you have the additive component of its motion to increase the winds in that area. However, as you're moving, and you also get a convergent pattern in the wind field as well. However, as you go faster and faster with these tornadoes and the forward speed increases, that right side of the tornado becomes even further enhanced, and the damage pattern really narrows and becomes skewed in the direction the tornado is moving, and it becomes almost more linear in nature, and you lose that really strong convergence signal you would see with a more traditional tornado moving at a slower speed. So then the question becomes, was this a tornado or a downburst? And in the absence of clear-cut evidence, which for the most of the time was what we were dealing with in this event, we had to weigh a number of different items to determine what the source of the damage really was. The first of which was the damage gradient and the intensity of the damage. And tornadoes tend to leave a really tight and narrow gradient in damage, a really tight, narrow path through whatever they're going through, while downbursts tend, and I underline tend, to be broader and weaker. That's not always the case. We also look at debris behavior. So once the debris was there, what did it do? Was there signs of debris disintegration? Was there signs of lofting and transporting well downwind of the source? And that's just something tornadoes tend to do. Downbursts tend to drill the debris into the ground. That's why you see trees flattened and debris just kind of flown into the ground, whereas tornadoes tend to loft debris more easily. And again, this is just more the typical patterns that we see. It's not always the case. Mother Nature likes to have exceptions. And those first two items, the gradient and the behavior, we then want to look for continuity in that signature. Do those signatures persist across a semi-contiguous path of damage indicators? So if it's going through a farmstead, and we're at a farmstead, and say there's a downed outbuilding, we want to see if, say, the surrounding trees to the upstream, to the upwind or downwind side, did they have damage as well? If it's more spotty in nature and we can't identify a clear-cut path, then we're leaning more towards a downburst in that scenario. And then finally, looking at the environment and the radar data, was a tornado actually supported here? This is where our science side comes into play, and we can leverage what the environment was like to help sway that decision if we're more on the fence. And as I said earlier, there was really complex wind patterns, and the terrain really added some weird twists to the storm survey. The tornado damage was often flanked by or even embedded within these downburst winds, and it just adds to the time it takes to assess the damage when you're out in the field and then construct the tracks when you're back at the office. And sometimes it seemed like the tornadoes tended to skip over that higher terrain and then come back down on the other side of a river valley. And so this is an example here on the right side of one such track, which is by Money Creek, Minnesota, just northwest of Houston. And the simple path that you probably saw in the news or you've seen elsewhere is that nice solid green line right there. Pretty straightforward, looks nothing much to write about. But then when you actually look at what the damage survey had to contend with, you'll see it's a much more complex pattern here, where we had multiple little semi-tornadic paths early on embedded within this broad wind swath, and then it seemed to actually jump this ridge line that was right here north of the Root River, and then came back down on the other side by Money Creek, and there was this broad downburst wind pattern on the initial part of the track before it tightened up. And then it continued with a pretty decent track until it got to the Winona County border, and then got more diffuse again and broad, and eventually we called the tornado to have dissipated right at the county border. And here's an example of those just plethora of damage swaths that we had to assess, some of them in very close proximity to one another. In some of the cases, these are only 2 or 3 miles apart each time. And this is, again, just an example of what we're contending with. The dots and the more pea green coloring polygons are the damage wind swaths, and the actual lines are the tornado tracks themselves. So wrapping things up here, the satellite data was something we were kind of excited to see what we could see. We've never really had a chance to use this, particularly this late in the fall and the winter time. You know, what would we see when we finally got a satellite pass? And we've had the ability to use satellite data for about the last 8 to 10 years or so through various satellites. And recently we've had the ability through the European Space Agency's Sentinel satellite program to get a decent resolution satellite pass that comes through every 2 to 4 days. And unfortunately, winter tends to be, or late fall and winter tends to be the cloudiest time of the season. And so even though we were getting satellite passes every few days, you know, December 17th was cloudy, the 22nd was cloudy, the 24th was cloudy, and we're kind of sitting there tapping our feet waiting for a good pass to really get and look at what we were going to see down there. And it took us upwards of 24 days to finally stitch together a complete picture of what the satellites were going to see based on the various passes that we got. And so these are some screenshot examples. And, you know, I was honestly just tickled to see anything, honestly, for this type of an event, because the farm fields had no corn stalks in them. It was all tilled over. We just had some corn stubble out there, or soybean stubble. Trees had no leaves. It was not an ideal setup whatsoever. And so the first pass we got over northeast Iowa on the 27th revealed upwards of 4 paths. We actually saw part of the Rudd Iowa path, and then 3 additional paths that we didn't know of yet. One of them was south of Marble Rock here. You can actually see that little line right there is that really enhanced right flank of the tornado, and you can see the inflow winds coming in on the side converging towards that tight line, that right flank. You see that same signature northwest of the town of North Washington. You see that really solid line, and that's the right flank of the tornado right there showing up on the satellite imagery. And then finally, you know, after some serious analysis and radar looking, there was a small path found west of Cresco. It was unfortunately degraded by snow cover and actually may still be there when the snow melts come the spring. But we could pick it out just a little bit through the snowpack when you did some comparison imagery, and you could see a little path coming through here and actually some damage further upstream to a farmstead. And surprisingly, it was the tracks through the heavily forested areas that were the easiest to pick out. And this is an example from Neilsville, the EF2 that Todd showed, and the blue arrows show where the path is. And you may wonder, well, how the heck did you figure out where that's going to be? The easiest way to do it was doing before and after comparisons in real time with the satellite imagery. So this is an example before and after comparison, and you see those tracks just stand out really incredibly well when you toggle the imagery back and forth between those 2 different data sets that were taken only a couple of weeks apart. So you can, again, the snowpack actually ended up aiding us, because all of a sudden with the trees gone, we saw more snow. So the areas that are whiter were the areas where the trees were down. And so that allowed us to find those paths. And as Todd said, we put all of this into an electronic database. It's available for anyone to see. It's all publicly available. We can post a link to that later, possibly on our webpage as well, to this data set that you can go through and peruse, and you can see every single damage point we put in there and some polygons for some of the tracks we had higher confidence on, and so forth. So finally, wrapping things up here on the last couple of slides, as we went through the survey process, the counting began. This is an example. This is a graph showing the number of tornadoes we had released through each day after the initial event. So by December 16th, we already had about 8 tornadoes. And as the days went on, by the 20th, that number kept going up. By the 20th, we were up to 18. And I color-coded the graph based on, the initial reports we got in the night of or the morning after the event. We went and surveyed those initially. But as I said, we kept getting reports for several days, weeks after the event. And so we were out surveying those well up to Christmas. And you can see those here in the brown line, those delayed reports. You can see the trend and the slope fall off. And then finally, after waiting for a while, we finally went and got our satellite analysis dealt with and found additional tracks as well to add to the database. So finally, last slide here, how does this rank on a historical note? Todd hit on some of this. This is the first ever documented for our forecast area. All these are number 1. The first tornado documented in the month of December. Largest single day tornado outbreak. It eclipsed the previous record by almost double. The previous record was 13. Most tornadoes in a single month, same number, 27, eclipsing the old record of 16 from 04. And this single event alone would have stood as the most tornadoes recorded in one calendar year. It brought our total for 2021 to 37, which beat the old record of 22. Looking a little bit broader at state records, it easily shattered Iowa's single day tornado outbreak number. 63 tornadoes, and maybe still counting. We're still finalizing the data there. It beat the old record by almost 2 times. The old record was 35, set in August of 2014. As you get more into Minnesota and Wisconsin, where the event wasn't quite as well centered, it was the 4th largest outbreak in Minnesota history, and it's all the way down to number 17 for Wisconsin. And as Todd said, this is one of the biggest tornado outbreaks in the nation amazingly. It's the 4th largest outbreak on record with 118 total tornadoes. And of course, the granddaddy of them all was the great super outbreak, or the great outbreak of April 27th, 2011, which had 362. So we're not going to be eclipsing that, but still, it's a very impressive event overall. And so with that, thank you for attending, and we'll take any questions now.